Yeah, as I said, thank you for taking time out of your schedules to listen to myself and my fellow presenters. As you may have noticed, I've started the day with a little bit of civil disobedience. My title differs from the one in the schedule, and that's because since marketing made the title, I didn't want to use one that took 2 slides. So, API updates versus uptime. Let me start with a show of hands. How many of you guys are using or have used NGINX? Yeah, that's pretty much as expected. How many of you have heard of or used NGINX unit? Disappointingly, that's also expected. But we'll fix that, So first, just housekeeping. NGINX was recently acquired by F5, so we are now a business unit within F5 Networks. So that's the commercial done. Let's have some dramatic music while the demo loads. So this is going to be mainly a demo-driven presentation. Come on, I know you want to. And I've cheated a little bit. I've created some JSON objects that we're going to use to configure unit. What is unit? Unit is our latest open source offering in NGINX. It's our polyglot application server, meaning that it can run multiple languages at the same time within the same unit. Cooler than that, you can run multiple versions of the same language within the same unit at the same time. And coolest of all, there's no config file. It's purely API-driven. This means you'll finally have the 100% uptime application server that you've been looking for. And since it supports multiple languages, it lends itself very neatly towards a microservices-oriented architecture, an API-driven architecture. Because to me, one of the key benefits of an API and microservices architecture is you're not constrained to one technology. You're not constrained to one language. You can use whatever language is best for the particular purpose and problem that you're trying to solve. With NGINX Unit as an application server, you get the same kind of control over all of those languages. I say all with a caveat. We don't support all the languages in the world. We're at 7 and counting, but we're getting there. And we have the main ones. Now, how does unit look? Unit looks very much like a terminal. Go away. Yep, we're here. And unit has a control mechanism, an API endpoint, effectively, that you expose in a certain manner. By default, it is exposed as a unit socket. I've done it a little bit less secure than that. I'm exposing it purely over HTTP. Obviously, you'd want to have stronger control over this because this is where all the magic happens. Right now, I have an empty configuration. Can everybody read the screen, or should I make the text bigger? Or it's fine? Excellent. So, as I said, I made the control socket very insecure, so I can see it here as well. I just updated it, and this is how my configuration looks at present. It doesn't exist in a file. Well, it does have a state file for reboots and stuff like that, but it exists in memory, so you'll do every reconfiguration as an API call. So let's try that. As I said, I've cheated a bit, and I don't want to fat finger the keyboard, so I also made my commands available for copy and paste. Clever of me. We'll go into the terminal and we'll issue the first command. What we're doing here is we're taking the content of a file I've called start.json and we're putting it into the configuration of unit on the socket in /applications. The content of start.json is very simple. It looks like this. So I'm defining 3 applications. Come on. So I'm defining 3 applications, app 1, app 2, and app 3. Since I'm not a developer, I've used PHP as an option. I'm defining where in the file system it should be looking for its content and what the default script is. So let's config that, shall we? Reconfiguration done. That sounds very promising. I haven't broken anything yet. And we see now that the configuration is in place. Let's double check that out here. Yes, indeed. We have our configuration. And it's purely JSON-based, so DevOps types will absolutely love this system. Now, I've defined my applications, and that's all well and good, but I can't access them yet. Why is that? Anybody? listeners. We need a listener. So I've cheated. I've created a listeners.json. It simply looks like this. I'm going to listen on all interfaces on port 80, and I'm going to pass traffic caught by that listener to applications app1 as I defined. Let's go ahead and actually let's just copy that command as well. Control tab. There we go. When I made the text bigger, it became a little bit problematic. There we go. And reconfiguration done. Do we trust it? We do, but trust but verify, as Reagan once said. Now, I have my listener and I have my application. What can I do when I have my listener and my application? Well, I can serve content. So now I have application 1 present. And this is the traditional way of doing things. This was unit 1.0, effectively. We're now at 1.12, if memory serves, so we have more elegant solutions for this. Because right now, all we're doing is we're listening on a port, we're listening on a port, 80, and we're just proxy passing that into app1. For the eagle-eyed observer, I'm port forwarding 8080 into the Docker container on port 80. That's why there's a mismatch. Anyways, so how can we make this more elegant? How can we make this more NGINX-y? NGINX-y, I like it. I'm going to use that for the future. Well, we can do routing. So I have a routing.json here. Actually, that text became a little bit too large. That looks like this. I define a route, which I have geniusly named route 1. And within it, I have a few matching criteria. I have a matching criteria first on the URI, which will match /*, so everything, so long as the method is get. And that will proxy pass to application 1, the application that we just saw. Then I have a second matching criteria, matching for a method that starts with P. What could that possibly be? You're all right. And that's passing to application 2, or app2 here. So let's go ahead and cheekily steal the command out from my cheat sheet. Come on, there we go. And we will go ahead and reconfigure. And the reconfiguration is done. Trust but verify. And we will see that we now have the routing or routes object populated with our data. Now, we're not done yet because the listener is still just proxy passing directly to app1. So what we need to do is we need to change the listener to this. Instead of proxy passing to application /app1, we proxy pass to the route that we created. So I'm going to go ahead and copy this fella. And not to there. I'm going to put it here. And the reconfiguration is done. Let's check that out, shall we? And yes, indeed, the proxy pass is now passing to route 1. Let's test that. We expect to see app1 here. And we do. If we go into the interface and we say curl 7.1 on 80, we see app1. But what happens if we curl with a p method like put? Hello. We now have routing in NGINX unit. And all of this, as you've seen, is configurable using API calls. So there's absolutely no back and forth with config files and reloads and worker processes being spun up or anything of that nature. Why is this important? Well, some application languages, the likes of Go and that style of languages, they kind of have the idea of operating as their own application server, right? But even so, having an application server encompassing it provides you a lot of opportunity. And that goes back to the uptime versus updates scenario. What happens in a Go application when you have to update the certificate? You have downtime. You have to have a tertiary strategy for uptime if you're going to use Go or other similar languages as their own application server. With NGINX unit, it's much simpler than that. Let's go ahead and put in a certificate. So I have a self-signed certificate. called self.pem. And it's simply, I mean, feel free to copy this. It's just a self-signed one, so you can't hack me. Haha. And we'll go ahead and copy out that command, and we'll upload the certificate using an API call. And then using a secondary API call, I'm going to modify a route. Oh, come on. There we go. I'm going to modify a route to implement that certificate. Now, if I go ahead and I have a look at my configuration, come on, there. I have a look at my configuration. We now have a certificate uploaded, and it is set on the listening port 83. I didn't use 443, my bad, but hey, it is what it is. So let's see, does this actually work? And I'm port forwarding, I believe, on 8083. And we need to specify. And there we are. We're now secure. Zero downtime on all of this. You want to update the certificate when it comes to expiry, zero downtime. Nothing gets recompiled, no code changes, no nothing. Nothing of the sort. Let's see here. I had one final thing I thought. Oh, yeah. So we had another thing we can do is if we go into our control tab, if we go into our start.json, routing, there. If I go into my routing.json, I can say app3. And I save that file. Now, if I go into this fella here, I can do a curl command. What are we going to do? We're going to put some data. And actually, I don't need to fat finger this. It's exactly the same command as I used before. I realized just now. Routes. There we go. If I reissue this command, boom, for the second URL, so that was the put, right? Curl, put, and we're gonna do HTTPS. No, that's probably still on the first listener. HTTP 127. How many sevens do we need in 127? And that was on port 80. We are now on a different application altogether. Now the script was ypka.php, so it seemed appropriate. Yeah, that is what I had prepared for you guys. If you guys want to see more about this, we're in the booth today and tomorrow. Feel free to pop by. And I'm also going to shamelessly shamelessly plug my colleague Liam Crilly's talk tomorrow at 1 o'clock in the Bankettsalen. That's going to be an interesting one to catch. Thank you so much.